Hi. So the question that we have right here is requiring us to evaluate the integral. So we have a good looking rational expression here, which is uh, x cubed divided by x plus 1. Okay. So one thing that I observe clearly here is that I'm unable to use U-substitution, at least in a convenient way. So what am I going to do? I'm going to use something a little bit um, just more like a manipulation. Like I'm just going to write this question in such a way that is going to be convenient for me to work it out. So if I look at my numerator here, which is x to the power 3, x to the power 3, I can choose to write this as x to the power 3 plus 1 minus 1. I haven't changed anything because this one here is equals to 0. So I'll try to write it in such a way that I don't change the meaning of the initial question. So I'll still say my integral. Then here I have x to the power 3. Then I say um, let me say I have plus 1 here minus 1 divided by x plus 1. We have dx here. So what I'm going to do here is that I'm going to try to separate this one here. So the idea is I'm trying to use the difference and sum of cubes. So the notation for difference and sum of cubes is that if you have a to the power 3 here plus b to the power 3, this is just going to be equals to it's just going to be equals to a plus b. Then you have a squared minus ab plus b squared. This is the sum of cubes. Then for the difference of cubes, we have like a to the power 3, um, a to the power 3 minus b to the power 3 is equals to, you're going to have a minus b here. Then what you have here is a squared, then plus ab plus b squared, like that. So what I would want to use is this one right here, like the sum of cubes. So this can be written as, like, I'm going to separate it. It's the integral of, I'm going to have x to the power 3 plus 1 divided by x plus 1, like this. Then I'll say minus, like this minus that I have here. Then I put 1 over x plus 1, then put dx here. If I want, actually, I can write these as individual integrals, okay, of which they're just going to be more like you have your dx here minus the integral. Here you have 1 over x plus 1, then you have dx there. Okay, so this one here, clearly I can also just raise this one to the power 3 because it doesn't change anything. Okay, so this one is pretty much easy to work with. Let's try to focus on this one. So I'll have like the integral, then on the denominator I still have x plus 1. Then for the numerator, that's the sum of cubes, which follows this format. So I'm just going to have I'm going to have my x here plus, which is a, then I have my b, which is a 1, then open bracket, that would be x squared minus a times b. So it's just basically x times this one. So that's just going to be x plus b squared, which is just a 1, like that. Then we have our dx here. Okay, so what you observe here is that this end, that cancels out. That's what I was trying to do initially, was just to cancel out the denominator, which is x plus 1. So here I can replace with what I've remained with, which is x squared minus x plus 1, like that. And I can go ahead and work out my integral. So for this one, I'm going to have like x to the power 3 divided by 3 minus x squared divided by 2. Then the integral of 1 is going to be x. Then I'll say minus. For this part here, if you integrate this one, you're just going to end up with natural log of x plus 1. Then we put the constant of integration, which is c, and this is our solution right here. So that's how we get to work out that question. Thank you very much for watching.